We'll jump through some of this stuff that we usually have here. Of course, Cimatron is for tool and die. It's a software that's comprehensive for all things having to do with design, as we talked about earlier. And now we're kind of looking at the end of the process. We're going to feature what we can do with NC, 3-axis, actually 2.5-axis, all the way up to 5-axis continuous. One of the key features we have is the ability to keep stock recognition along the way with each tool path. We'll dabble a bit with the machine simulation, and then we've got two other products, well, not really products, but elements we need to deal with when it comes to die build, and that's, of course, wire EDM, and an important thing of like drilling holes, things like that, that's so time consuming and tedious, and how we can automate that. So with that, we'll jump right into this. So I decided the best way to present this is just take the die form right off the part that we were working with. I'm going to orient this into the place, much like I would right on the table of the machine that I'm working with. So a simple bit of part organization where I'm helping the system to see what I'm calling the part surfaces. That's where the part's actually going to be formed, and then pretty much everything else. I've got a couple of drill holes for socket head cap screws. I want to fill those up, so I've got quick functionality just to find the tops of those holes, fill them into place for me so that I know I'm not going to let the cutter accidentally waterfall down into there. All right. And understanding that what I'm really doing here is teaching the software the way I like to cut as I go through this process of setting this up in a few minutes. Once I've taught it that, I'll save this information in a template, and that's going to be a recurring theme as we go through this presentation. That template, I then can just say, here's the part to cut. Now here's how I want you to cut it. It knows the machine, it knows the tooling, everything, the speeds, all that set into place for me. I'm doing a little technique here where I've got a sharp corner. I know that I'm going to put a ball end mill in there. So instead of leaving it sharp, I'm going to put a radius on the corner of that flat face. And that way I've got something that allows it to do a little bit of a wrap instead of it staying glued down on that corner. And you'll see how that makes for a nice, easy way of flowing through there. And again, the idea is I want to capture that shape into the right little set I've got here. Set is like a layer or a level, if you're used to those words. And I can teach the system, I want you to cut this way with this set, cut another way with this set. All right, so now I'm loading my tool library. I can have several different libraries. All of them can be aware of the material that they're cutting. We can also manipulate these different libraries. And the idea behind this is once I've set my tooling, I can keep it the same no matter what. Let me click on here. Okay, just let someone in. And it's always the same. That's the key thing. It can be in whatever particular pot I want, but importantly that I can make sure I've got my speeds and feeds set when I'm working with that tooling. All right, we've loaded up the machine. We know what post we're going to use. So when we do our simulation, we can simulate right on the machine itself and capture all those machine motions, which means we're checking to see not just that the holder is not violating the part, but that the machine itself is not traveling or trying to travel beyond its limits. We tell the system too what block we're starting with, what's the overall size. Here I want to give it a little bit of height, or call it stock, and here's a number of ways that we can build the stock. I'm just saying grab the part, throw a rectangle around it, give me 2 mil extra on top, and that's what I'm going to start cutting with. The other thing was called the target. That's what am I going to cut to. Do I want to stick to 3-axis, go up to 5-axis? It's all there. It's just depending upon what my license has available for me. We'll do our first rough cut. You can see there's a huge library of different cutting styles that you can use, different types of tool paths. And the idea is to be robust and versatile, but at the same time, when we get down to it, we want it to be simple and fairly automated. So I picked the geometry, I went and picked the tool, setting up a few things like I want my clearance to be optimized. I want to know exactly how much material I'm going to leave here, so maybe I'll type in 2 millimeters for part offset, that's remaining material, and let's preview it. show me what it's going to look like right after I cut it. So it's actually doing a stock calculation so that I can see that I'm getting into those areas. What's the remaining material? Once I rough it, this is the area I need to really target with my re-rough or my second rough. That helps me know that my logic is good, so I'll go ahead and run it. While it's running, I can be setting up the next toolpath, or I can open up another window of Cimatron and go ahead with another job. All right, so here you can see the cutter motions now as it takes its first rough cut. And if we want to, we can isolate so we just see what the cutter path motions look like. Okay, so I'm going through, check now my stock. You can see the 2 mil everywhere, plus the stair stepping that goes on with that bull cutter. So let's grab a secondary cutter. This one time it's going to be 25 millimeter. You can apply it to the same part surfaces. And when I look at remaining stock and material here, I can see what that's going to do. So again, see it whittling down further and further into that stock area. Maybe we'll try a smaller cutter and take a look at the preview of the stock. Okay, well, see, I'm leaving a lot less now with that 20 mil as opposed to the 25 mil. Thinking that's the good one to go with, we'll use that tool. I'll set it up with a few things that are different, like maybe changed a few things on my trajectory. Everything less than 1 mil, we're not going to worry about. And now we calculate. So you can see I'm working quickly because I'm really trying to cram everything in here. But you can see that a lot of times I can just take the previous tool path, cut and paste it, change a couple parameters, and keep right on going. All of this will have greater meaning too. Let's see, here we go. As we go further along, okay? Because again, like I said, I'm teaching us the system the way I want to cut. All right, so now we're ready to move on to more of like a semi-finish. All right, so we'll grab a finish mill by limit angle, and because we're going to leave stock, it can become our semi-finish. Working with the same set of faces as before, it already loads it for me. It's just going to be a matter of now how I want to set up my down step and side step. You notice I'm working with a horizontal step and also a vertical step. So it can have different strategies, like I'm doing a spiral cut down like in a Z level, but then a lace cut going back and forth across the verticals or the near verticals, the near flats. And as I work through this, I want to separate these faces a little better so that I know I'm targeting my Z levels and my flats. All right, so lots of ways to pick different geometry. All right, I'm going to say I want to pick everything that's continuous or flowing together, like you see here. Everything that has something tangent between it. And then I want to exclude these flats again. So we want the cutter to go down into that bottom radius like you see here. And then everything else, I'm just going to set up as a check surface. In other words, come up to it, but don't cut it. That way I get a good, nice, clean, continuous Z-level path going down those angled walls. Okay, we've set up a few more parameters here. Maybe we're just going to leave 1/2 mil on the semi and then let it calculate. As I'm building up each of these different cutter paths, I'm taking the time to rename them because I won't always remember unless I do, right? Plus, anytime I label it like that, again, if I reuse it, it will continue to hold that label for me. So there you saw the Z-level semi that we're going to do. Now a remachine, you might call it corner picking. A lot of people call that, or rest milling is a term that I've heard other people use quite a bit. And it's basically going to look at the areas that are left behind where the stock is. So this is a true stock recognition toolpath, just like the others. So it's more than just saying, okay, I know I need to get into the corner that was left behind by this previous cutter. It does use that, like I'm setting up now some cutters to do just that. But it also is going to keep track of stock. So if there are thick areas of stock, I can go back and do like a mini rough routine in there. I'm saying I left everything at 16 millimeter, but now cut it with a 10 millimeter. And then apply the different side steps and vertical steps. So we'll calculate that now. A couple of options that are available. One might, here I'm doing everything from the cutter params, which means load up the speeds and feeds. And again, I don't have to actually go and type those in every time. It's just with the cutter. All right, but the options that's available is if the cutter is too short, and we want to try to get as short a cutter as we can for stability. But if it's too short, then swap it out and finish that toolpath with the next longest cutter. So you can set up a series of lengths of cutters to do that. Or you can say, okay, if it's going to get too short, I want you to automatically tip. So if you have 5-axis, you can incorporate tipping as it gets deeper and deeper, okay? And there you can see that nice cutter just targeting the corner where there's material. And the stock, you can see it's starting to look even. There's stock on that flat floor. You can see it there standing up a bit. So let's say we're going to add a new procedure to just get that flat floor, but I'm going to stick it in first. I wanted to get that first before I did the sidewalls, let's say. All right, so with that, I'll use the same routines that I've used before, but instead, let's try to use a flat cutter. That would make a lot more sense, wouldn't it? So you see it in my tool, my shank, my holder, all that gets fully gouge checked. And we want to change it just to planes only. So again, we've got different ways of cutting with standard, climb cutting, keeping everything optimized for tool retracts. And because I put that floor cut in before I did the sidewalls, you see in the sequence of events there, just is asking me now to recalculate those previous tool paths. Okay. And it makes sense because it knows the stock changed. So it's going to ask me to update those tool paths. That means then if that flat went in there and took out an area, the next cutters are not going to go after it. Okay. So you can see it's smart. There's a lot that you can do with it. It's extremely, extremely powerful in terms of what's available for your cutter path. And I'm trying to, even though I sped this up for the sake of our webinar, I'm trying to show you real time too what it takes to do this. So honestly, we've spent maybe about 10 minutes, somewhere 10 to 12 minutes to get these cutter paths down. Now I'm doing a little bit of tweaking, part surface offset. I want to cut down to the part itself now with my last finish cuts. I'm basically copying one, bringing it down, and then changing the parameters so that it does a finish. All right, pretty straightforward then. Here we're down to our last ball cutter, where we're going to finish everything in those green faces. Okay, a few more. You can see now my side step and down step. I'll need to change those. We'll tighten those up and get the better finish that we need. Parallel cut instead of conventional. We can do mixed, go back and forth. We can check our vertical angles. In this case, we're going to cut verticals using a climb method. Everything looks good. And go right ahead then and we'll be able to execute that. Oh, yes, and the high-speed options. You can put rounds on for different high speed. Of course, that's if you have the high-speed machine and you want to take advantage of that. When we're done, we'll post it out to whichever machine you want it to post to. We provide posts. We have a very extensive library of 3-axis posts we can start with. But from there, we can customize it to the machine if there are particular things that you want to post out. Likewise, we can post everything to 5-axis machines as well, or anything in between. Okay, just a few more seconds here and we'll have all our progression done. Now we're going to, of course, want to see, did we remove all the stock? And then our motions, are they looking good? It's always advantageous to check your stock. So now you see I'm doing the calculation that updates that last stock statement, and we'll know what exactly we have left that we need to check. Okay, so we can go ahead and bring this in to our simulator. And like I said, what we're doing here is actually checking the entire sequence of these cutter paths, right? And you can see it's got the whole machine here, so any cutter motion that might exceed a limit of one of the axes will give us an error statement. You know, this is obviously a 5-axis machine too, as you can tell by the rotation on the table there. But here we go, cutting through our first rough cut. And as you can see, it's doing a nice, what we call a Z level down, basic, rough. There are a couple areas where I'm going to skip ahead just because I know you know what a simulator looks like, and good graphics for it. Let's turn off the column so that we can see just where the tool and the holder are. And we'll go through a few of the motions just so you can see, how it simulates. There it goes to the back, down the side. Here's our next re-roughing. It's dealing with mostly the corners, the trench. There was our flat only. Now we're doing the semi, working our way down to Z. And then finally, you'd see the colors change with each tool path. At any point, you can stop, you can interrogate it. You have the ability even to check right down to the toolpath node to check for location. This is one of the advantages of course, having that stock statement, is we're not wasting our time cutting air. And on a remachine, that's so important. If it gets into a corner, we want it to finish that corner instead of picking up, moving over, then picking up again and moving over. We call it that sewing machine effect. That's just a waste of time that's valuable. So the toolpath is then that way optimized or made smarter just so it stays in the areas it needs to stay in. All right, here you see it Z leveling a corner, and then you'll see it go across top corners like through there, and now that's doing a nice collapse cut where you can actually see the motions on it. All right. Finally, we're into our finishes. And through it all, we haven't done anything. We have no errors showing up on each step. So all in all, we could say that with the simulation and everything, the verification we're using, that it's going to be a nice, clean series of tool paths that we could post now to the machine.
Yeah, he's the one supposed to approve it. Yeah, because he's the one do the tool buy off.
Sure.
I think
Yeah.
I would say at least a couple of weeks, 3 weeks ago, he done more than that. But I don't know if it has anything outstanding.
I think someone has a conversation going right now. Let me find out if I can mute. Okay, I think we're good. Go back here. All right. All right, so like I said, we can take all the information that we've accrued here, the knowledge of what we're going to do to make these tool paths. We know the cutters, we know the machine, we know the ideal speeds and feeds. All we really need to do is just apply to a different set of geometry. So one more thing that I'll do here to double check this, I get a little further along here, is to save it as a template and then rerun the template again on this part just to make sure it picks everything like it's supposed to. And then I'm reassured that I can use that template again on any other jobs. And it's not necessarily that the job has to be this particular shape, right, or a similar shape. It could be something different. It just needs to use the same tooling series, which typically I'm going to rough similarly, if not the same. I'm going to do the same kind of semi. Now all that's left is corner picking and then getting back in there with the finish. And you can see how it's separated in the finish, those Z levels working its way down nice and clean. Now it's going across the tops, staying on the top. And then you'll see it go down and take out the middle area. So smart tool path that works in zones, not jumping here, there, everywhere. Right? All right, so for tooling, good advantage to using this. Of course, a lot of what you do in die is going to be frankly, it's going to be on a wire EDM or a hole popper, a drill. We'll spend some time on that in particular, but the strength of the software, you got to show the 3-axis, 5-axis machining capabilities. And by 5-axis, I'm really focusing on just the tilting. That's the one thing that we've seen that applies the most for tool making. A lot of people are using 5-axis now because the machines are cheaper. And they like that with 5-axis, it's more like a 3+2 that they're doing. They're doing 3-axis tool paths, but they're doing it across different setups. So basically they rotate the part 90 degrees, or rotate the insert 90 degrees and cut it from the side, flip it over again, cut it that way. So a quick stock analysis here, right within the simulation, gives us a breakdown of a distance away from where we've actually tried to cut it. You can give the resolution a second. All right, so it gives you an idea if you're cutting down all the way, or most importantly, if for some dumb reason, you see that something has perhaps violated, it should show you that something like that occurred. The only time that could happen is if you actually messed up a tool library. And, some people still do that when they do a remachine because they lie about the tool, make it something oversized or undersized. You can use exact tool sizes with Cimatron. Okay, so I save the template. Now I'm going to apply it. And I want to make sure that everything comes across. And then we'll say, go ahead and execute. It loads everything up. And now I'll see everything is calculating. While I'm doing that, I can switch over to another session of Cimatron, and I can start working on another one of the forms. So let's bring in another die form. Similar but different, you can see some of the similarities there. Go ahead and set it up. I want to rotate that lengthwise on the X-axis of my machine. I had a few things I did before, like I wanted to plug those holes where I've got the socket head cap screws. I wanted to set up my different sets. You can see the sets are already there. It's just a matter of telling it what particular parts of this insert I want to have on that set, and then pick it as you see appropriate. So pick all that by color. That goes on to what we're calling the beyond part area, which is basically the run out binder area. And then we'll take what's in the middle. That's the actual part area. And now, since those sets are named the same, we can go ahead and apply that template by looking for set name. Okay. Oh, let's see. One more thing to do is to capture those caps, NC caps, over the socket head cap screws. And just box pick. There it is. Say OK. That's built. Now I want to put it on the set, and also I want to give it the correct color. So I'll just go to the appropriate set, which is the one called 3D Area Beyond Part. And we would take that and glue that into that set. Okay, now we'll apply the template. It's the same one we applied before. And say execute. That's it. So you can see once you've taught it how you want to cut, it's just a matter of applying the template. Now I jumped ahead in time to where the template had run through everything, and here you can see the cutter paths that are loaded. We can go back at each stage. We can check the stock to see how it's been built. Here you can see that re-rough going right down the center. I'm sorry, that's the cleanup. That's a remachine. And how it's just targeting those corners. Take all that to simulation, run it on the same machine, and we can see that the cutter path can be checked and verified. So there's the initial stock. Now I'm coming through roughing it, a re-rough, do a little bit of another re-rough here. You can see I'm doing the semi. And again, you've seen what the simulator looks like, so we don't need to spend a whole lot of time on it. But that's basically how the 3-axis machining works. and the use of templates is used. All right, so a little bit about our wire EDM. I've got the plate that I'm going to do some wire machining. You can see there's all kinds of machines already pre-built, if you will, preloaded inside our wire EDM. I'm going to use just the Charmy here, and I want to set up my first cut. I've got some typical die pockets, cutting areas that I need to deal with here in this die plate. So basically it has a 1/4 inch land, and then it's got some taper for the slug to drop through. So let's just tell it right here in this area, I want to pick these faces. And you can likewise work with just 2D geometry if that's what you have, if you're working right off a PDF or print, something like that. So in this case, it's a Cimatron generated plate I'm working with. All right, so it knows the geometry now, and it's broken it into 2 zones. You can see GO2, GO3. We describe how we want it to come in with our entry of our wire. So I might say I want to come off 3 mil off of the length of the part right here, or right here off this midpoint of the line. That's my entry of the wire, so that's where my 1/8 or 3/16 drill hole would go to have that wire start. That can also be designed as part of what we're doing with our die design package. All right, so you can see the entry. Everything is almost set up. We want to be able to do like a variable conic with this as well. With the inclusion of our machine, it knows mostly everything that it needs. So it's just a matter of setting up some particulars about the cut itself. What direction do we want to do? Or do we want to go completely rough all the way? Do we want to rough till remnant? Do we want to come back and cut the remnant? Do we want to do a skim cut across the part and then skim the remnant? In this case, I want to do the angled wall and just rough cut it and then let the slug drop. Then I want to come back and do another rough across the land and come back and finish the land. That's in place, so I go ahead and rough it. Cut and paste. Change it to skimming, and then calculate. Likewise up here, do the same. It already knows the geometry. We'll go ahead now and enter using the same hole. There's our point. It's kind of arbitrarily just drawing it out, but it knows it needs to be 3 mil of entry. And again, let's say go ahead and rough that through. So I've set up my entry point. We're going to go back to variable conic again and let that completely rough. All right, so 3 paths are built here. Again, save it, save the way you're doing it, and then apply it to the next shaped hole. If it's something that you're going to do, your wire EDMing with. Likewise, I do the same when it comes to cutting the punches, and just keep applying the template again and again until I get everything done the way I want. Simulation here is nice as well. Several ways you can go through simulating it. I'm just going to do a simple follow the path here. So you see it's roughing on the angled wall right now, going all the way through. Let it drop, come back, rough again across the land. And this can go super, super fast. That's why I like to do this. Come back and skim. Done. So that simply is how we can go about doing the wire EDMing, and that's really all the steps that are needed. It's just a matter of the particulars of your machine. Okay, jumping over now to auto drill, another process that takes a lot of work for the programmer here. Same plate, but now I'm looking at the drill holes, the taps. I'm looking at the areas where I would want to go in and spiral out the counter bores. Okay. So it's simply going to be a 3-axis routine. I call it drill. I'm going to build my drill procedure here. We use what we call drill and then 3-axis automatic drilling. You might have noticed if you caught it real quick that it does also do 5-axis drilling. So I need to identify parts and like holes. I'm going to tell it to go through, select all of the holes that apply to drilling. So you see it leaves the top flats out. It leaves the wire EDM pieces out as well. I want to do a management of these tools, which means group them. So you see over on the right, we've got holes that are blind, holes that are free, holes that form pockets. And when we group them, it now has found sizes that are alike. Or maybe it's a socket head cap screw. It may be longer, it may be shorter in different places. That's okay, as long as it's alike in how its machinability would work. Now I'm going to take sequences or a set of templates, if you will, and apply them. So I've got this library of different hole types I want to build. It goes out and finds where it applies to that hole, loads the cutter, and away we go. Okay. Here you can see I can say, like, I'm setting up, I want to cut with a spot drill from ST to someplace in the down a little further, and then I want to come back with a clear drill. It says a high-speed peck. I want to go all the way to the bottom. And then I've got the pocket, so I might come back with my counter drill, counter bore. And you can see all the cycles that are already set up, ready to go for you. So typically, I mean, a lot of stuff would be drilling, high-speed peck, counter boring, drilling, tapping, over and over again in this one step. It will find all the like holes for me and go out and grab it. Plus, there's some smarts to it. Like, we'll go into calculating it, and then we'll do a simulation of this. So maybe it's used the same drill 3 or 4 times with different holes, or something like a spot drill. Especially, it would use that. If we simulate running the spot drill first here, we can see how it takes those different types of tools and it groups them, right? If I wanted to spot here and then here, so it's not doing a tool change, running through a one hole, then coming over, doing all the tool changes on the next hole. It's gone through and made it smart. And then with each of the times that I run something, I can go ahead and check my remaining material. We can use the whole machine if we want when we do the simulation. You know, it's whatever makes sense to you to help you get the job done quicker. So here I'm saying, just give me the quick simulator. And there we go. Same simulator as before, but so there's all the holes with the spot drills. Now I'm coming back with another drill that is used in multiple places with different holes. Now you see me doing some circle mill patterns, working my way down. So I can use that same end mill on different size circle mills. It's just, again, a matter of what I set up in my sequences. So hopefully you've seen some power behind this, where you can tackle an unusual circumstance should it come up. You've got the capability to do all kinds of different types of cutter path, but you also have the ability to make it simple in that you just teach it how you want to do it, save the template, run that across the next job, run it off in the background even, come back, your cutter paths are there ready to be simulated. We do very little manual editing, if any. You can if you wish to. If you want to, crop out a line or something like that, I'll come back and I'm doing a faster. I sped it up so we can see it all. And now you can see it's already been roughed out. Now I'm coming back and doing a finish in some of those circle hole patterns. So I've got a true helical finish. Okay. I think with that, I've about wrapped it up. So I'm just going to go ahead and jump on to our next slide here. That way we have some time for any questions. And Joe, if you'd like to open your mic up too, we can answer these together.
Absolutely, certainly. Is there any questions? Mohammed, I wasn't sure if that was you're speaking with an employer or you had questions. Anything from your end? Yeah, actually,
No,
we
sure.
wrapped up.
Sorry.
Well,
Sorry,
that's
John.
okay.
No,
Mohammed,
I by mistake, I just unmute myself. So,
great. Did you have any questions as we were going
No,
along? I wasn't sure.
no, thank you. I'm good. Like,
Thank you.
machining is not my alley kind of thing.
Sure. Well, I do appreciate everyone coming in for our webinar. Being that this is the last session, we thought we may run short, and we did, and that's okay. I think this kind of brings us to the end of everything, unless anyone has any questions on the machining.
There's one thing a point I wanted to make. I was hoping someone would ask it, but it's okay. If there's a change in your design, things always go through engineering changes that, changes what you're about to cut. We will know that change has occurred. So let's say you've gone through and you've programmed it, but you've already roughed it on the machine. We'll bring that change in, and now you can see if your rough cut violated anywhere, or if you can use it still and just recalculate it. Right. So we have knowledge of what's happening, where the design is always checking, or the NC is always checking the design to make sure that everything is up to date for you. So you're not cutting a previous version.